Alright, John, so the last thing that I'm going to do with you today is kind of just go over some practice questions. I just took a look, and it looks like for Chapter 10 there is a quiz as well as a test. So I'm going to have to get a hold of Miss Tompkins and ask her which one came first, or I don't really know what the deal is, but I think that there were 2 grades for this unit, so don't do anything until you hear from me about that. But I did, however, find a practice quiz. Now, I'm going to go over some of these questions with you. It says Chapter 10 Trig Practice Quiz up on the top. If you have a copy of this, I would like you to grab it right now, pause this video, and work through it with me. And then I'm not going to be able to do all the questions with you, but you can finish the rest on your own. I don't know if that was a homework assignment or not. Chapter 10, practice quiz. I don't believe that it was. I am going to have to double check that. Okay, so find Chapter 10, practice quiz, and then let's go through some of them together. So, alright, number 1. Number 1 says, if cosecant theta is equal to -2, then we have to find what the value of sine theta is equal to. Okay, now we know that cosecant is actually 1 over sine theta. So if I know that cosecant is equal to -2, then what is sine theta equal to? Well, in order to figure that out, you could just cross multiply. So -2 sine theta is equal to 1. And get that sine theta all by itself by dividing by -2. So sine theta is equal to -1/2. Okay? That was number 1 on the practice test. Number 2. Oops, I don't want to do that. Number 2. Find the numerical value of 5 cosecant 40 degrees times sine of 40 degrees. Now, this is one of the questions where you kind of want to express everything in terms of sine and cosine because they're our most basic elements, and then maybe see if something happens, see if something reduces. So this is really 5 times. Cosecant is the reciprocal of sine, so 1 over sine of 40 degrees multiplied by sine of 40. And you can see that because I have a sine 40 in the numerator and a sine 40 in the denominator, I can simply cancel those out, and this whole expression is actually just equal to 5. So things like this, questions like this that look really complicated, typically are not as complicated as they seem because something is going to cancel out. Okay? Number 3. If sine of 6a is equal to cosine of 9a, then we have to find the measure of angle A. Okay, well, this is stuff that we just went over. They're cofunctions. Sine and cosine are cos functions, so if you remember, that means that they're complementary, meaning that their angles, or these angles, have to add up to be 90 degrees. So 6a plus 9a have to add up to be 90 degrees. So that is 15a is equal to 90, which means that a is equal to 6 degrees, which is choice C. Okay? Number 4 is pretty much the same thing. Number 5 is also the same thing. Number 6 is pretty much the same thing. Let me go through one of these with you. How about number 5? They're all just dealing with that whole cofunction issue, and all you have to do is add them up and set it equal to 0. So this time we have cosine of x is equal to the sine of 2x minus 30. So because sine and cosine are cofunctions, I'm going to say x plus 2x minus 30 is equal to 90. So that's the same as saying 3x is equal to, I'm going to add that 30 over to the other side, so 3x is equal to 120. X is equal to 40 degrees. Okay. Number 6 is the same thing, number 7 is the same thing, and number 8 is the same thing. All you're doing is taking those two angles, as long as they're cofunctions, setting it equal to 90, and solving for either theta, solving for x, solving for a, whatever. Alrighty, let me see how much time we've got. Alright, let's do a new page. I am now onto the second page of the practice test because I think that these questions are a little bit more tricky. Okay, so number 9. If sine theta is equal to negative 4/5 and it's in quadrant 4, we need to find the value of tangent theta. Okay, so as soon as you see a question like this, you should be thinking SOHCAHTOA. So sine is opposite over hypotenuse. So we need to find that missing side, but I also want to think about what quadrant I'm in. So all students take calculus. You can see that because we are down here in the 4th quadrant, that means that tangent is going to be negative. So I'm going to write that negative right now before I forget. Tangent is opposite over adjacent, so I know that this is a negative 4 right here. I still have to find the adjacent side, and if you notice, one more time, the Pythagorean triple 3, 4, 5 comes into effect. I don't even have to do the Pythagorean theorem because I know that this time it really is a triple because the 5 is the hypotenuse and that's the biggest number. So the adjacent side, the missing side is 3, and that's it. I'm done. The answer is tangent theta is equal to negative 4/3. Okay? Alrighty. Number 10. Number 10. This is one of the ones where we're going to have to find all 6 of the remaining trig functions. Okay? So, theta is an angle in standard position in quadrant 2. And it says that sine theta is 12 over 13. That's the information that it gives us, and it wants the rest of the trig functions. So I'm going to do a couple of things. I'm going to write SOHCAHTOA. I'm going to think about which quadrant I'm in. And in this case, I'm in the 2nd quadrant. And then I'm also going to list out everything that I'm going to need to solve for. So sine theta, cosine theta, tangent, secant, cosecant, and cotangent. Now because I'm in the 2nd quadrant, that means that sine and cosecant Sine and cosecant are both positive, but the rest of my values are going to be negative. So this is negative cosine, negative secant, negative tangent, and negative cotangent. Okay, now that I did that, I can finish the rest. Okay, so I have a triangle. And I'm going to make this my theta. So sine, I know, is opposite over hypotenuse. So my opposite side is 12, my hypotenuse is 13. Let's figure out what my adjacent or my missing side is. So I'm going to check how much time I have. 12 squared plus x squared is equal to 13 squared. 12 squared is 144 plus x squared is equal to 169. When I subtract that, I'm going to get x squared is equal to 25. So that means that my x is 5. So my adjacent or my missing side is 5 right here. So let's go up here and fill in all the values that we need. We already know what sine is. Sine is 12 over 13, which means that cosecant is 13 over 12. Cosine is adjacent over hypotenuse, so 5 over 13. Secant is 13 over 5. And then tangent is opposite over adjacent. 12 over 5 and 5 over 12. Okay. I think I'm going to stop right here. And then, actually, I have 3 more minutes. Maybe I'll just keep going. Let's do another one. Alright, number 11. This is one of the ones where you start to use the trig identities. So the trig identities were your reciprocal identities. So cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent. The quotient identities, where tangent is sine over cosine, cotangent is cosine over sine. And then the Pythagorean identity, so sine squared theta plus cosine squared theta is equal to 1. 1 plus cotangent squared theta is equal to cosecant squared theta, and then the other ones, and you should have them written down somewhere in your notes. So that's going to come into play right here. So it says express cosine squared theta plus sine squared theta plus tangent squared theta as a single trig function. Okay, so this is what I mean by using your trig identities to make things simpler. So hopefully you could look at this part right here, cosine squared theta plus sine squared theta, and recognize that that's one of our identities, and we know that that is equal to 1. So we're left with 1 plus tangent squared theta. And 1 plus tangent squared theta is actually one of our other identities, and 1 plus tangent squared theta is actually just equal to secant squared theta. Okay, so hopefully, John, you have those written down somewhere. I can go through and review all of them for you if you need me to, but that's what we mean by expressing it in terms of one single trig function. We kind of used our identities and went through and we simplified things as we went just to rewrite it in terms of 1. The only thing I will warn you about is making sure that you are making these values squared every single time. Okay? And I'll be right back.